Let's go to page 561. This is lesson 12-3. The objective of this lesson is to define trigonometric functions of the general angles. Okay, so we learned about how to find the angles before, but now it's going to be a general angle, means it can be anywhere. But before we do that, we need to get some basics done. Okay, so first you need to know the basic ratios. So sine of theta equal to y over r. So when you have an angle, let's say right over here, so this is r, that's your y, and that's your x, and here's your so this is your theta. Okay, so you're going to have sine, cosine. Cosine is going to be the x or the horizontal over the radius or the hypotenuse. Okay, tangent theta will equal to the vertical over is a slope, so it'd be y over x. Okay, and obviously this cannot equal to 0, right? Denominator cannot equal to 0, or else it would be undefined. And then cosecant would be just reciprocal to be r over y, so y cannot be equal to 0. Okay, and secant theta would be r over x, and cotangent theta would be x over y. So these are basics. Also, some more basic things you need to know is your spatial triangles. Okay, in geometry, you know that the spatial triangle will be like 3, 4, 5 triangle, right? You're going to see that a lot. Okay, also you can see the multiple of that. Okay, like 6, 8, 10, right? That if you double that, you get that. Or the triple of that, so it would be 9, 12, 15. So you're going to see this kind of triple quite often, so spatial triangle. So make sure you recognize them. Okay, and it's kind of easy to recognize. Okay, so like if the first number is odd, what you do is you square that, and so square of that equal to 9, and we equal to 2 consecutive numbers, 4 plus 5, right? Okay, so now you only do that with if you start with the basic the relative prime numbers. Okay, and the next one you're going to see is 5. Okay, and again if you square that, you're going to get 25, so it'd be 12 and 13. Okay, and if you double that, you get 10, 24, 26. So recognize these. Okay, and next one would be 7. So 7 squared would be 49, so it'd be 24, 25. Okay, so these are the one that you start with odd. Now the one that you're going to come across often is 8, 15, 17. Okay. Again, if it's even, what you do is you divide by 2, so you get 4, and you square that, you get 16, and you go on either side. Okay, so you go to get the nearest integer. For the odd numbers, you square, so square you get 49, divide by 2, you get 24.5, and you get the one on either side. Okay, but so there are some tricks to that. But these are the spatial triple that you should recognize from your geometry. You're going to see this quite often. Okay, so let's go to example 1. Okay, so you have an angle that passing through 8, negative 15, and you're going to get the 6 trigonometric ratios. Okay, so if you don't know your spatial triple, you have to use Pythagorean Theorem. Okay, you have to use a squared plus b squared equal to c squared. Okay, now if you're going to do this one, so you need to follow that. Okay, and again you don't have to make all the lines, just kind of sketch it out. So 8, that's 8 right over here, so that's 8 over here, right? And now this is about twice as that, so and it's negative, so you have to go down. Okay, so make this about twice. Again, all you have to do is just estimate. Okay, and this is negative 15. So for this section, you have to watch out the positive negatives. So this is positive, so you go this way, right? That's your x, and that's your y. Okay, so positive and negative. Okay, so x and y can be positive or negative, but the radius or the hypotenuse is always positive. And again, so here's your 8, 15. See over here, there's 8, 15, 17. Okay, so if you don't know your triple, you have to use Pythagorean Theorem. You have to do the 8 squared plus negative 15 squared equal to c squared, so you got 64. Now negative squared positive, right? So it'd be 225. Okay, and give you 289 equal to c squared, and c equal to 17. So if you don't know that, you have to do the long way. Okay, so once you do that, now you can go and get your 6 ratios, right? So sine theta, okay? Now sine theta, I kind of like to use a vertical, so sine would be this, so it would be, or the opposite of a hypotenuse would be negative 15 over 17, okay? And cosine theta would be this over that, so it would be 8 over 17. And tangent theta would be this over that, so it would be negative 15 over 8. So you can make sure you know your ratio. Then once you get the primary, the secondary, you can just reciprocal, right? So CSC will equal to negative 17 over 15. And cosine go with secant would be equal to 17 over 8. And cotangent would equal to, flip it over, so it would be negative 8 over 15. Okay, and that's the answer for example 1. Okay. Okay, so again, make sure you know your triple. You make things a lot easier to do. Okay. Okay. Now let's go to page 562. And here's a table of the quadrants. So instead of making the table, what you do is, here's your quadrant 1, quadrant 2, and quadrant 3, quadrant 4, okay? And so over here, the quadrant 1 over here, right? Everything's positive, okay? So in quadrant 1, okay, let's go and make the table. So you have the sine, and the one go with the sine would be cosecant. So this kind of go together, okay? Because they just take the reciprocal, right? And you have the quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? So over here, everything is positive, okay? So quadrant 1 is positive for everybody, okay? So sine, cosine, secant, and tangent, and cotangent, okay? So quadrant 1, everything's all positive. Now, when you get to quadrant 2, notice that this is a negative, this is positive, okay? So this is positive, 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 okay? So sine is this over that, so it would be positive, and therefore cosecant also positive. Cosine is this over this, so it would be negative over positive, so it would be negative. And therefore secant would be also that. Okay, tangent is sine over cosine, is this over this, right? So tangent is this over this, so it would be negative. Okay, so again, if you don't remember, just go and draw your triangle. It helps you to kind of remember. Okay, and now when you get to quadrant 3, okay, this is negative, and hypotenuse is always positive. Okay, so sine is this over this, so it would be negative. Okay, cosine is this over this, would be negative. Tangent is this over this, so negative over negative will give you positive. Okay, now we get to the quadrant 4, so this is positive, this is negative, positive, okay? So again, from here, so sine is this over this, so sine is this 2, so it would be negative. Cosine is this 2, so it would be positive. Tangent is this over this, so this 2, so it would be negative. See that? So that's where this table comes from. If you just draw your triangle and label plus or minus, you can figure it out very easily, okay? Okay, let's go to example 2. Okay, so determine which functions are defined for 180 degrees. Okay. So over here, so this is 0 degrees, 90 degrees, because this is a right angle, right? And this is 180 degrees because it's a straight angle. So you're looking for this over here, okay? So you're looking for all the functions, see if it's defined. Okay, so again, let's go and do this. So sine theta is vertical. So what you do is you can just pick a point, like right over here, and let's go and use the lowest integer. So this would be negative 1, 0. Okay, so that's your x and the y, and because this is, remember, r is a radius, right? So in this case, r equal to 1. R is a radius and it's a distance, so it's always positive. Okay, but x and the y, you have to watch the direction. Okay, so sine is the vertical or the y. Okay, so sine equal to the vertical or the y over the r. So this is equal to 0 over 1, so equal to 0. Okay, And the way to easily remember is, remember sine is vertical, so over here vertical is 0, so sine equal to 0. That's the easy way to remember. Okay, cosine theta equal to x over r. Okay, and so in this case, you're going to get negative 1 over 1, so equal to negative 1. Okay, so that's negative 1. And tangent theta is equal to the y over the x, right? That's a slope. Remember, tangent is a slope. Okay, so by looking at that, what's the slope of that? Equal to 0, right? Because y equal to 0 and x equal to negative 1, so equal to 0. Okay. Now, once you get this 3, now to get the other 3, sine, so you can get cosecant, right? Cosecant theta equal to flip it over, so it'd be 1 over 0. So this is undefined. Okay, so this is undefined. And secant theta would be flip it over, would give you negative 1. Okay. And cotangent theta, you flip it over, you get 1 over 0. So again, these two are undefined. Okay. So for this one, this is undefined. So cosecant of, actually it's 180. Okay, cosecant of 180 degrees is undefined. And cotangent of 180 equal to undefined. Okay, because you cannot have over 0, right? So that's how you figure it out. Okay. Okay. Next thing is you have to do something called the reference angle and reference triangle. So on page 562, let's say if you have theta equal to 300 degrees, okay? So when you draw these, right? Here's your 0 degrees, 90 degrees, 180 degrees, here's your 270. So 300 is going to be at right over here, right? 270, so go, remember one number on the clock equal to 30 degrees, right? So this is 6 o'clock, so this would be 5 o'clock, okay? So first what you need to do, you always go up and down to draw a triangle, okay? So once you get your angle, okay, so again, step 1, okay, draw angle. Okay, then you go up and down, so go vertical. Again, never go sideways, always go up and down, okay? So this is called a reference triangle, okay? So this is called a reference triangle. Okay, and the angle that you have, this is called an alpha. So alpha is the reference angle. Okay, so the angle inside the triangle is your reference, it's called a reference angle. So again, first you draw your angle and you always go up and down to make a triangle. The triangle you make is called the reference triangle. And the angle inside is called a reference angle. Okay, so reference triangle, reference angle. And reference angle is always going to be between 0 and 90. Okay, it's going to be between 0 and 90. Okay. And so over here, now to figure out this angle, all you have to do is you just go to find the angle in between. You have to use the terminal side minus the beginning side. So what you do is use a higher number minus a lower number to get an alpha. Okay. And so in this case, so this is the 300 degree, right? So in this case, so you have to use a high number. So this is 360. Okay. So again, you have to use this side. You cannot use 0. So use 360. So alpha will equal to use, so equal to one side, the one that is more counterclockwise. Okay, use the one that's more counterclockwise minus the one before it. So alpha will be equal to 360 minus 300. So alpha equal to 60 degrees. So alpha is always positive. So that's how you figure your angle. Okay? Okay, so let's go over some examples. So example 3a, so theta equal to 140, and you're looking for reference angle alpha. So you can first draw your angle. So 140, so here's your 90, and here's your 180, okay? So draw 140, so here's your 140 degrees. Okay, so to figure out this alpha, so you have to use a big angle minus small angle. Okay, so alpha equal to 180 minus 140 degrees, so alpha equal to 40 degrees. Okay, for A. Now do B. So example 3b, you got theta equal to 300 degrees and 10 minutes. Okay, so again, so here's your, so 90, 180, 270, and 360, right? So 300 is about right over here. So this is 310 minutes, right? You can always go up and down. Here's your alpha, right? So to find alpha, you have to use big number minus small number, or the end minus the beginning, right? So alpha equal to 360 degrees minus 300 degrees and 10 minutes. Okay. So this is going to give you 59 degrees and 50 minutes. You can use your calculator to do that. Okay. Okay, let's go to do C. Okay, for 3C, you got theta equal to negative 135. Okay, negative 135 degrees. Okay, so here's 0, so you have to go backward. So this is negative 90, negative 180. Okay, so negative 135 is about right over here. Okay, again, always go up and down to draw your triangle. Never go sideways, always go up and down. So here's your alpha. So in this case, your alpha is going to be, again, use this angle minus this angle. Okay, and so you go to negative 180 minus negative 135, right? And so this one, you're going to end up with negative 45 degrees, right? But what you need to do is take absolute value, okay? Because when you go backward, you have to make an opposite. So just take absolute value, okay? Because alpha is always positive, so equal to 45 degrees, okay? Okay. Another option to do this is, another way to do this is you just find the coterminal. So sometimes the negative is kind of harder to do. So what you do is you add 360. Okay, use the coterminal angles. So this will equal to 225 degrees. So now when you draw your triangle, so here's your 0, 90 degrees, 180, 270. So 225 will be right over here. Right? So that's 225 degrees. Right? I can draw that and make it alpha. So in this case, your alpha will equal to 225 minus 180. So alpha equal to 45 degrees. Okay. So normally the positive way easier to work with. Okay. Okay. Now next thing is, let's go to page 563 and example 4. Okay. Okay, so you want to write cosine of 200 degrees as a function of the acute angle. Means you want to make this between 0 and 90. Okay, so you want to make this equal to cosine of something. Okay, now again, you want to draw that. So here's your 0, 90 degrees, 180, and 270. So 200 is going to be about right over here. Okay, so here's your 200. Now we learned about reference angle, right? Okay, so reference angle is this minus that, so this is going to be equal to 20 degrees because 200 minus 180 will give you 20 degrees. So that's your alpha, okay? So the reference angle is this. You just go and flip it. So you either have to kind of flip it over or move to here. So you want to use You want to draw a triangle using the 20 degrees. Okay, so it's going to be, so basically in this way, you just go straight, so you end up with this. So they are 20 degrees. Okay, so this is equal to cosine of 20 degrees. Okay, so again, you want to use a reference angle. So what you want to do, you want to make this into a reference angle. Okay, now the things you have to watch out for is you have to make a plus minus, because cosine is this right over here. Okay, so this is negative, right? So now when we move it to the quadrant 1, so again, when you want to make an acute angle, means you want to move this triangle to the quadrant 1. So when you make it to quadrant 1 with the same angle, okay, so now the cosine is right over here, and this is positive, okay? See that? So this one is negative, okay? This will give you negative. This will give you positive. So now they are not equal. So to compensate for it, you need to make a negative right over here. Okay, you need to put a negative right over here. Okay, so that's what it's equal to. Okay, so the things you have to watch out for is to convert. What you need to do is first you have to figure out the alpha. So from here you have to figure out the alpha. The next thing you have to do is you have to figure out, are they the same or opposite? If they're opposite, then you have to put a negative to compensate for it. If they're the same, okay, then you don't have to do anything to it. Okay, so that's kind of the trick. Okay, okay, so let's go and do example 5 to kind of use that again. Okay, so example 5a. Okay, so you want to find exact value. So tangent. So this one you got tangent of 330 degrees. Okay, so this is a different problem. So this kind of just tell you need to, when you're going to move this to quadrant 1, you have to watch out for positive, negative. Again, if they're opposite, you have to put negative over here to compensate for it. Okay, if they're the same sign, like for example, like sine. If you were to do sine, okay, and I'm just using an example. So let's say if you have sine of 200 degrees, okay, in this case, this will equal to sine of 20 degrees, right? But notice the sign. In this case, the sign is what? So if you look over here, right now the sign is over here. It's negative, okay? And when you move to over here, right now the sign over here is positive. So again, it's opposite. So in this case, what you need to do, you have to make it compensate for it. Okay. Now how about tangent? Okay. What happens? You have tangent of 200. Well, tangent of 200 is the slope. So in this case, it's negative over negative, okay? So it's positive, okay? And you change into tangent of 20 degrees. Well, 20 degrees, this is, over here is minus, right? See over here, this sign, so it's negative. I color code for you, okay? So negative over negative. So this is going to equal to positive. So tangent of 20 degrees would be equal to the positive over positive. So this is equal to positive. So since they're the same, then you don't have to do anything to it. Okay, so they are found already. So again, if they're opposite, okay, see the sign. So again, if they're opposite, right? If they're opposite, you have to put negative to compensate for it. Okay, over here, if they're opposite, you have to put negative over here, right? Now the slope, okay, so slope is positive. Over here the slope is positive. So they have the same slope. They have the same slope, so you don't have to do anything to it. Okay, so that's what this is for. Okay, so let's go and find exact value. So this one, again, the 330, so it'd be 0, 90, 180, 270. 330 would be right over here, would be a 4 o'clock position. Okay, so here it's just 330 degrees. So again, so this would be 360. I'm going to make this a little bit bigger. So it's just 0 and you're 360. So you always put 0 and 360. So you can see the difference is 30. So this would be 30 degrees. Now, once you know that this is 30 degrees, so this is a 30-60 spatial triangle. Okay. So when you do that, then you can go ahead and do the 1, 2, square root of 3, right? That's your spatial triangle. But you have to watch, okay? This is a negative now. You have to watch because this is going down. So this is a negative y. Okay, so you have to put in the number, then you have to watch your positive, negative. Okay, so tangent of 330, tangent is the opposite of adjacent, so it'd be negative 1 over square root of 3. And you simplify, right? So it'd be negative 1 over square root of 3. Okay, that's how you figure out the answer. Okay. Now let's go and do B, 5B. You're looking for cosecant of negative 225 degrees. Okay? So again, first let's go and draw our triangle. So here's your 0. We're going this way. You know, I don't like 225, so I'm going to add 360. Okay? So this is equal to cosecant of 535, 135. Okay? So this would be right over here. Okay, so it would be 135 degrees, and this is 180. So alpha would be 45 degrees. Okay, so again, so get your angle, draw your reference triangle, get your reference angle. Okay, then put 3 sides. So this is a 45 spatial triangle. So your number would be 1, 1, square root of 2. Right? So putting the number, then you have to watch out your positive, negative. Okay, notice this is a negative x, so this has to be a negative. This is going up, so it's positive, so it's fine. Okay? Now, cosecant came from sine. So let's go and do the sine first. Okay? So sine of 135 degrees, so sine is this over that. So equal to 1 over square root of 2. Okay? So cosecant of 135 would be just flip it over, so equal to square root of 2. Okay? And that's it. Okay. Okay. Let's go to example 6. It says find the other 5 trigonometric functions of theta if cosine theta equal to negative 2 over 5 and 180 is less than theta less than 360 degrees. Okay, so what you need to do is go and draw that, okay? Draw that picture. So remember, cosine is a horizontal, okay? So the bottom is, so this is equal to the x over r. So you have to go negative 2, so that's your negative 2, and over 5. So you got 2 choices, okay? You can have over 5, or you can have 5 over here, okay? So this will give you 2 choices. It can be here, like negative 2 over 5 or negative 2 over 5, okay? So that's why you need to have an additional clue to tell you which triangle is correct, the one you need. So it's between 180 and 360. So here's your 180, and here's your 0 and 360 degrees. So the angle they're looking for is between here, so that means this is not the one, okay? Okay, then after that, you have to use your Pythagorean Theorem, okay? So you have to figure out this side. So a squared plus b squared equal to c squared. So you're going to get negative 2 squared plus b squared equal to 5 squared. So 4 plus b squared equal to 25. So b squared equal to 21. So b equal to square root of 21. Okay? Okay, so once you get all 3 sides, then you can write your functions. Okay? So sine theta equal to this over this, right? So again, you have to know your function. So sine theta equal to square root of 21 over 5 is the opposite, or the vertical over the hypotenuse, right? And cosine theta is the horizontal over the hypotenuse, so it would be equal to negative 2 over 5. Okay, and tangent theta equal to this over that is sine over cosine or the y over the x. So it would be equal to square root of 21 over negative 2. So I'm going to put negative on top. Okay. Okay. So that's what I have so far. Then after I get the 3 primary one, okay, after I get the 3 primary, then I'm going to do the flipping over. So cosecant of theta equal to 5 over square root of 21. And you have to multiply by square root of 21, square root of 21 to simplify that. So it'd be 5 square root of 21 over 21. Okay? And oh wait, sine, this is negative. You got to watch out, right? This is going down, so it's negative. So I have to watch out. So this would be negative over negative, so equal to square root of 21 over 2. Okay? Okay, so you have to watch out for, so cosecant would be, okay, so I'm going to put negative on top. Okay, cosine go with secant. So secant would be just flip this over, so it would be negative 5 over 2. Okay, and cotangent, cotangent would be flip this over, so it would be 2 over square root of 21. Then to simplify, you have to multiply by square root of 21. So you go to 2 square root of 21 over 21. Okay, and those are your 6 functions. Okay, so you have to use information that you have, draw your triangle, and then go and use Pythagorean Theorem to get a third side. Okay, and then from there you just use your functions. But you got to know your ratios.